So now let's discuss differentiation of expressions of types ax plus b to the power n, so ax plus b whole to the power n, and 1 over ax plus b whole to the power n. So we'll differentiate both of these, and n can be any natural number. So 1, 2, 3, 4, 5, 6 and so forth. So we find the derivative of ax plus b whole to the power n and 1 over ax plus b whole to the power n from the first principles when n is any natural number. So n belongs to the natural numbers set. So we'll apply the binomial theorem. And basically the binomial theorem is very crucial to any derivative with regard by using the first principle, or by definition. So ax plus b whole to the power n can be found by this particular binomial expansion. So what this basically is, that this n, this basic bracket, these brackets, what do they really mean? Basically these brackets are this. So for example, if you had a long bracket which said say 7 and 3, this would basically translate into n factorial, and n in this case is 7, so 7 factorial over r factorial, which is r is 3 over here, so 3 factorial into n minus r factorial, so 7 minus 3 factorial, which is basically 4 factorial. So this is what basically these long brackets mean, and we'll apply, and this is the rest of the formula for the binomial theorem. These are the brackets, and other than that you can see that there are a and b, the two variables over here. So the power of a starts with n, which is the original power given in the question, and the power of b in the very first term is 0. And as you move on further, the power of a decreases till it reaches 0, and the power of b increases from 0 till it reaches n, and that is the binomial theorem. So and also the value of r, basically it starts from 0 and going on it ends at n, so the last bracket will be n and n. So this is this covered. So the first example is that we have to find from definition the differential coefficient of ax plus b to the power whole to the power n from the first principle. And basically the differential coefficient is basically the derivative that we have to find by the first principle, and we discussed how to do that by using the binomial theorem. So let y be equal to ax plus b to the power n, and n is a positive integer. And you remember the 4 steps. Obviously this is by definition or by from the first principle. So the first step was to take the increment on both sides. So any place with a y becomes y plus delta y, and any place with an x becomes x plus delta x. So this x over here becomes x plus delta x, and b is a constant. Remember that b is a constant, just like a is a constant, so b remains as it is. So now once you expand this, it becomes ax plus a delta x plus b whole to the power n. And now you can basically write this ax plus b in one place and this a plus a to the delta x in one place, and we'll see why we have done that. So this is what you have, and now you'll apply the binomial theorem on the right hand side. And as you remember, this ax plus b to the power n is the first term, and by the way, the reason why we have this is because this is the term that has n and 0 in its basically be multiplied with it, and that just results in 1 really. So this just remains at it, and now we go on further and further and further till we reach this. So basically you can see that the value of ax plus b, the power of ax plus b is being decreased, and the power of a delta x is increasing. Because remember that as in the binomial expansion, that was in terms of a and b. Basically we'll treat this ax plus b as a and this a delta x as b, and so now you can see why we're doing this. So the power of ax plus b will decrease from n till at the end it becomes 0, so it just becomes 1, because anything to the power 0 becomes 1, and the power of a delta x is increasing till it reaches n. And by the way, another reason for why we have ax plus b whole to the power n over here is because it was being multiplied with a delta x to the power 0, which is just 1. So this and a delta x to the power 0, it just results in 1. And similar is the case for this last term, the first term and the last term. The last term is basically being multiplied with n, and it is also being multiplied with ax plus b whole to the power 0, because n will be subtracted from n, which is just 0. And this also results in 1, which is why we're just left with this a delta x to the power n. So now you can see that we've taken this positive y to the right hand side and it becomes this negative y. So what we'll do now is we'll go to step 2, which was to put the value of y from equation 1 into this equation. So this negative y will be replaced with negative ax plus b to the power n, because originally in the question basically the equation that was given to us was y is equal to ax plus b to the power n. So now what you'll do is you can cancel out these two terms, because ax plus b to the power n minus ax plus b to the power n is just 0. So you're left with this now. And what you can do now is you can take delta x common, because now every single term will have at least one a delta x term. So you'll take delta x common, and now you're left with this in the bracket. Now step 3, divide both sides by delta x. So this becomes delta y over delta x, and this dx over dx will be cancelled out. And now you'll go to step 4, which is take the limit as delta x approaches 0 on both sides. This, as you remember, is the final form of the derivative of y with respect to x. So this is just f prime of x, and that is what we have to find. And over here you'll apply the limit. Now delta x approaches 0, so every delta x term inside this bracket becomes 0. So see here, only the first term, this term, has no delta x term, so it will remain as it is, and every single term ahead of this has at least one delta x term, and the last term is delta x to the power n minus 1, I guess. Yeah. So what we'll do is every single thing after this first term is being multiplied with at least one delta x term. So every single term after the first term becomes 0, and so at the end you're just left with this. And thus dy by dx, this was y, so dy by dx is equal to n into, oh by the way, this is just n because n long bracket n and 1 is just 1, so this is the final answer that you get.